here. And let's form two confidence intervals. Let's form two confidence intervals. Actually, yeah, we'll do them over here and then write them over there. Let's form intervals around L1 and L2. Yes, T intervals, I think. Fire them up. T intervals number 8. We haven't used these in a while. We got data. L1's my first data set. Chances are it already says 1 from your exam, I'm guessing. Alright, so if I have cantilever breaks, according to my tests, I'm going to break between 22 and 24 feet. Here's my breaking distance. And you got to realize too, this is only breaking distance indicated on dry pavement, horizontal dry pavement, going a certain speed. I'm hoping that speed was relatively constant on every trial. But we're not talking about trail conditions, we're talking about loose gravel, we're talking about dry pavement. So there's some limitations there. Much of my commuting is done on dry pavement, quite a bit of it's done on dirt, some of it's done in snow, hail, sleet, rain, fog, less than ideal conditions. Which reminds me, if you haven't turned your sprinklers off yet, please turn them off. It's starting to scare the piss out of me on 12th Street, coming up to you on 12th Street, as the water's running down in the bike lane, freezing as it's going, and I'm right. So please turn your sprinklers off for me. Thank you. Much appreciated. Okay, so there's my stopping distances with cantilevers, yes? Let's check it with V-brakes. Same thing, except change it to L2. Good. All right. How am I doing with V-brakes? Looks like I stopped between about 16 and 17 feet. Right. Summarize results over here. Okay, good. Right. How do we feel about V-brakes? Was it a worthwhile investment?
Yes.
Statistically significantly, it appears to be, yes? What's the minimum measurable difference in the two types of brakes? According to my sample, including the margin of error. What's the minimum? Kaylee, go!
5.
5 feet! Because the lowest braking distance with the cantilevers is a 22. The highest with these is a 17. That's a 5-foot difference at least, yes? 5 feet at least difference. Awesome. What confidence did I just do that before that test at?
95.
Careful! Did I?
Squared.
Didn't hit 95% squared. Remember, we ran 2 separate intervals. We're actually down to 90% confidence, aren't we? No. How do we get back to 95% confidence? There's a couple ways you can do it. What's one way we can do it? There is one way you can do this.
Just increase the confidence level?
Yes! Laura, thank you. You could just increase the confidence to 97.5%. I think gets the job done. I'm going to check that. I remember, I'm doing this from your last exam, your last take-home exam. If we square 97.5%, Laura, I think that gets us back to 95-ish%. It's almost 95%. It's close enough. So if we increase our confidence to 97.5%, then we can run 2 separate intervals. Yes? What's going to happen to those intervals with an increase in confidence? Do you remember this from your first exam? You might not. It's okay if you know. What's going to happen when you increase confidence on intervals?
They go down.
They actually go up. Yeah, they get wider. And here, run them again to see. Okay? Rerun the intervals, and then we'll talk about why.
No, I see.
No, but I want you to know why too. Good. Oh, gotcha. The distance between goes down. Yes, the difference goes down. Thank you, Rosie. You change this bad boy to 0.975. This is V-brakes. This is V-brakes. It's thinking. Now it's a 16 to 17, which still rounds to the same, but the decimals are actually closer out to 16 and 17. What Rosie said was the difference between the intervals is going to get smaller, and she's right, because the intervals themselves got wider. Correct? Good. Now, we still see significance. Maybe not quite as much. Maybe it's 4 feet of difference now versus 5 feet of difference, but we still have a minimum measurable difference, and now we're back at 95% confidence. Yes, this is quite good. This is quite good. Can anybody think of why we would not want to do what Laura just told us to do, which by the way was awesome? Is there any potential backlash from what Laura told us to do? Any. And this is okay if you're not seeing exactly how this is. What happens when you raise confidence? Besides the interval getting wider and all that stuff. What happens? Ooh, hang on a second, let me back this out.
Isn't it more likely to have more margin of error or something like that?
In a very special place, yes, yes. Thank you, ladies. Hang on one second, I gotta call up a graphic that I have to locate real quick. Yep, don't need this anymore. What I need, and I'll leave you to think about this for next time. Oh, not Visual Studio. Okay, just don't click. That happened first. I want you to look, and you might not have gotten this far on the homework yet, and that's okay. But if you look at the one mean hypothesis test homework, I had you guys look at, in this, I had you guys look at beta, chance of type 2 error. Now we're talking about chance of type 1 error all the time, yes? What's the chance of type 1 error in this class? Always. At 95% confidence, it's 5%. Because what you do is you set up a cutoff that's out here that leaves 5% in the tail. And you always do that. We always do that. That's what the kind of definition of 95% confidence is, or 5% significance. If you want to raise the confidence, okay, now this is a left tail test that we're looking at here. We'll come back to testing our data on Tuesday together. If you want to raise the confidence, and this is the cutoff for 95%, where does my hand have to go in order to raise the confidence of the null curve? Forget this curve for a second. This is the null curve. Where does my hand have to go if I'm going to raise the confidence? Danny, go ahead, be brave. It's got to go this way, doesn't it? Because we have to have less area in this tail, which makes it harder for the data point to get out there, which is the definition of increased confidence. The confidence interval gets wider. Here's your interval. It's going to get wider with 97.5% confidence, which is going to make this area over here smaller. Beautiful, thank you. Thank you, that's perfect. So at first glance, it's like, why wouldn't we just go like 99.9999999% confidence, yeah? And then just make it as hard as possible, because then when something happens, we know it's super significant. Well, then here's the thing. If you do that, if you keep pushing the confidence interval out and out and out and out and out and out, it's going to be harder and harder for the data to actually be out there. So you're going to have a truly extreme set of data to actually get the test statistic out there. And that's assuming that your null hypothesis is right, which we always do, yes? But isn't it possible the null hypothesis is wrong? Of course, that's what we're going to test, yes? If the null hypothesis is wrong, that means there's some other curve down here. That means there's some other curve down here. And here's the trade-off of a type 1 and a type 2 error. This region right here indicates the type 2 error region. This error indicates the type 1 error region. This is a true negative. This is a true positive. And if you don't get this in 4 minutes, that's okay. Go back and look at this resource for you online. What happens as we slide this guy over and make the chance of a type 1 error less? As that line pulls, what's happened to the chance of a type 2 error? It's going up. Which means as your chance of a false positive goes down, your chance of a false negative actually goes up. That's the trick, Laura. And of course you wouldn't have seen that coming, because I keep saying, we'll talk about that eventually. Well, here we are eventually, talking about type 2 error now. So we want to keep it at 95%. That is that perfect juggling match of less type 1, less type 2 minimized. But now we need a freaking test to do it with. But we're not going to learn that in 2 minutes, are we? No. So let's get out of here for the weekend. That's a perfect little alarm for us. Go out the weekend. We'll see you on Tuesday. Is the project due Tuesday yet? Are there Tuesdays due Tuesday?
Yes,
That can't be
no,
right.
the exam is due Tuesday.
And the project is Thursday. Okay, good. I like it that way. And I think I put a quiz up for you guys too, should you choose to want to do it on Thursday. If you don't have to, that's totally fine. Have a good weekend. Be well. Rest up. Stay healthy. This weather, it's relentless. It's not going to let you stay healthy unless you make yourself stay healthy.
How long is the weather going to stay as nice as it was yesterday?
I don't know. You're in bed. I mean, I climbed at Smith in t-shirts and shorts and